Good evening, dear participant, and welcome to big biostatistics workshop from basic to advanced techniques. Today is the third day, and we are going to cover statistical inferences part 1. And during this session, today, resource person will be Dr. Harmanpreet Singh Kapoor, Department of Mathematics and Statistics, Central University of Punjab, Bathinda. This event is going to organize jointly with the Mathematical Thinking Foundation and Baba Farid Group of Institutions, Bathinda, India. Before inviting him, I would like to introduce Dr. Harmanpreet Singh Kapoor. He serves as assistant professor in the Department of Mathematics and Statistics at the Central University of Punjab. He holds a PhD in statistics from Punjab University, Chandigarh, where he also earned an MSc in statistics, graduating as a gold medalist. Dr. Kapoor has extensive professional qualification, having passed multiple actuarial examination from the Institute of Actuaries of India, covering various topics from financial mathematics to business economics. With over 11 years of research experience, Dr. Kapoor's interest span actuarial statistics, statistical modeling, inferential statistics, biostatistics. He also received research grants, including a significant DST serve-funded project on socioeconomic externalities of groundwater depletion in Punjab. Dr. Kapoor has published numerous research papers in prestigious journals, collaborating with the prominent scholars in the field. He is an active member of several professional bodies, including the Firm of Industrial and Applied Mathematics and Institute of Actuaries of India. His teaching career began at Baba Farid College and has flourished at the Central University of Punjab since 2015. He is recognized for his contribution to academia, having organized and participated in various national and international conferences, workshops, and seminars. Dr. Kapoor has also been invited to deliver expert lectures on statistical applications and research methodologies, and he actively contribute to e-content development and student projects. In various activities which we have organized usually based on the statistical part and its applications in various branches of sciences. Many times we invite Dr. Kapoor for his valuable talk and expertise. And I hope that this session will also be very wonderful, informative, useful to all the participants. Also, I hope after the end of this session, there will be a brief introduction about the R plumbing, how we can install if there will be spare time. And tomorrow we will have the sessions with R plumbing. So links how to install R software and R studio. Both will be shared with you. Dear participant, also please let me know I am perfect audible. Is there any kind of issue related to my voice? My voice is stable or not? Audible, okay. Yes. So during the session, we are allowed to all of you to unmute your mic. If you have any question during the session, you can unmute your mic. But it's my humble request to please keep muted if there is no question from your side. Now I would like to invite our resource person, Dr. Kapoor. Welcome, dear professor, in this session. And now we can start the session. Over to you.
Okay, thank you, Dr. Mehchan. Thanks for the nice introduction. So, good evening, morning, and good afternoon. I don't know from where you got connected to this workshop. So, today we are going to cover a very important topic in bioscience or biostatistics, that is called statistical inference. I think I'm audible to all of you, right?
Yes, sir. Perfect audible. And audience, please let us know if there is any issue related to voice.
Okay. So, hope you have enjoyed the first 2 days of the workshop, and you have covered very important topics in those 2 days. So now my role is that to take you further. So, Dr. Meherchand, can you allow me to share my screen?
Yes, you can. Just 1 minute, sir. 1 minute. I make you co-host. Yes, now you can share your screen.
Okay, thank you. As Dr. Meherchand has given me responsibility to help to introduce you with the concept of statistical inference. So in the statistical inference, before going to introduce this topic, so in the today's session, what we are going to cover, let me give you a brief about that. Okay, so we will not only cover that statistical inference, we will also try to do some examples in some of the one of the two software, either Excel or R, based upon the that means based upon the timing that we will have in further of a session. So let me start today's session with a very simple introduction that we know that we have a very major branch that is called statistics, and in which we will not only discuss that how to collect the data, how to take a sample. Okay, it will also help you to extract inference from the observations, right? So we segment statistics to two major branches. One is called descriptive statistics, and you can unmute yourself if you have any query, or you can put a query on the chat box also, so that simultaneously I can answer your query if you have any query. And second one is called inferential. So if can anyone can give me some brief about this two topics? One is called descriptive and second one is called inferential. Any idea or any guess? What under these two major branches, what is the major difference and why they have these two branches? Anyone from the audience? I'm audible, right?
Yes, sir. You are perfect audible.
Okay. Okay. So can anyone participate in the discussion so that I can proceed further based upon your response? Otherwise, I will explain to you. If there is no one who can explain, then I can explain it to you. There is no any problem with that. So let me explain it to you that in the statistics we already have discussed that we will have some data, and when we will only talk about the data that we have in our hand, we only present the data, we only summarize the data, okay, and we just try to extract information only for the data set that is available to us. For that, we will only use descriptive statistics tools, in which we will cover central tendency measures. I think all of you are aware about the topic central tendency measure. Okay, in which we consider some of the most commonly used measures like mean, median, and mode. And I'm assuming you are aware about this thing because this is not the talk. That means not my talk today. That I am not going to cover these topics today. I want to more emphasize on the inferential part. So the second one was measure of dispersion. I think all of you have heard about this thing, in which we will cover variance, standard deviation, standard error, range, mean deviation about mean deviation about arbitrary constant, and so on. Okay. So now, so as already discussed with you that in the descriptive statistics, So we have some sample, we have some information from the population. We only talk about that observation only. We never say that. So whatever the inference, we never discuss that. We only talk about that sample only, or part of the population only, and we try to summarize uh, this data set using some these measures, and we try to write our conclusion. So now, what's the difference between descriptive and inferential? Now, in the inferential, so we have an objective that is related to some population, but we are not able, we do not have resources with us that we can consider all the observations from the population. So what we will do is we will take some samples. Okay, and we will take some samples and we try to get information or extract information from these samples and try to generalize the results from the sample to the from the sample for the whole population. So for that, we will go with the inferential statistics techniques. I think the difference will be clear to all of you. Okay, so in the inferential statistics, we have further two branches. One is called estimation, and second is called testing of hypothesis. Okay, so now as already discussed with you that we will only have access to sample, and we try to generalize, we try to get information from the sample, and we try to generalize the result that we got from the sample for the whole population. So one way what we can do is we can take one sample and try to estimate the population parameter. Now let me tell you what is the meaning of population parameter. So generally mathematics or statistics, we assume that our x is a variable that follows some distribution. So I'm assuming that it follows normal distribution mu and sigma square with parameter mu and sigma square. I think all of you are aware about this term or terminology, parameter mu and sigma square, because if you are doing biostats and if you are dealing with biostatistics, then normal distribution is the most common distribution that is used in this for the study of biosciences, right? So we have two parameters. So, but the problem is we do not have access to the population observation. We have only access to the samples. That is some part of the population that we have access with. So what we do is we use some tools, or you can say we have some techniques or methods that help us to estimate these values, mu and sigma square. And the function that help us to estimate these parameters is called estimate. Okay, so this estimator form will change based upon the parameter. So let us suppose we have one function that is called x bar that can be used to estimate the parameter mu. We have another form that is called s square. That is an estimator that is used to estimate sigma square. Okay, so I'm not going to discuss a lot about the mathematical thing. I just want to help you to understand what we are doing and why we are doing. Okay, so estimation means that we will take some samples, and based upon the sample, we put we construct a function of sample observation, and these sample observation can be used to estimate the population parameter. And whatever the estimate we got from the sample, that can be generalized for the whole population. And this is the main objective in the estimation theory. So we want our estimator, or estimation basically is a function of sample observation. So we want our estimator should satisfy some of the properties. The first property is called unbiasedness. Unbiasedness means that on average, our function of sample observation must be equivalent to the, or must follow the population parameter. For example, I want to give one example here. So let us suppose you want to study the consumption of food. Okay, or you can say you want to study the expenditure of a society. That means how much expenditure a person has, those are living in a society. So in a society, we are saying that there are 500 persons, or 500 families are staying in a society. So now, so it is not possible to ask each and every member in the society, okay, and know about their expenditure. So, and it is very you can say genuine thing. That means genuine thing that comes to your mind, that no one will give you the exact figure. So we are assuming that they are giving us the exact figure that how much they are spending on monthly basis. So in a family of 500, we will take only 50 families and we consider this 50 family as a sample observation. Okay, so now based upon the sample observation, so we got some average of expenditure on monthly basis. So now how can I say that? So whatever the families that I have considered and whatever the value I got on average basis, that can be generalized for the whole family members that are staying in the society that consists of 500 families. Okay, so for that, I want whatever the value I got from these 50 family members, that should be accurate enough, or that should cover every segment of the families that are staying in the society. Hope this idea is clear to all of you. So here, so our main objective is that our technique or method that we will adopt to take the sample of this 50 families from the 500 samples, that should be good enough so that it captures each and every segment that are staying in the society. Okay, and whatever the value we get, that should represent the whole society in very without any bias, or you can say doubt. Okay, so this is the main objective. So in the estimation, we have further two techniques. The first technique is called point estimation. And the second is called interval estimation or confidence interval. Okay, let me tell you that why these two techniques are different. So now, as we have discussed that we have taken 50 observations from the society and take the average, or you can use any of the measures given below. Either you can take mean, median, mode. Okay, and that can be used to represent the whole society expenditure. So now when you change the sample observation, so let us suppose I have whatever the samples I have considered at the first time, I am now not taking those. Hello. Hello. Does anyone has any query?
No query, sir. Please carry on.
Okay, so what I was trying to say. So now we can see that if we skip or we exclude those 50 persons, now we are going to take sample from the remaining 540 persons. Okay, so now you can easily see that your estimate will change. The average expenditure of the for that sample that we have taken new, okay, that will be different from the average value that we got from the first 50 sample observation. So now point estimation, what is point estimation? Point estimation say that whatever the sample that we have taken first time, so we got one value. So when you take another sample, we got different value, or it may be close to the previous value, but it should not be equal to the previous value. To overcome this drawback, what we do is,
saboda a lokacin mun so a bashi sometimes saboda a yi transforming ita waɗannan gidan.
Can you mute yourself if you're not, if you do not have any query? I think it would be more convenient for other persons also.
Santar ina jin an riga.
Okay, so now what I'm trying to So now we know that when we change the sample, so our point estimate, point means when we change the sample, our value, average value, we keep on changing. So to overcome this drawback, what we can do is we can construct an interval. So we can say that with in this interval, we will try to find a lower and upper value. Okay, because when we keep on changing the sample, so our estimate will change. So what we can do is we can also derive an interval, and we can say that our most of the values lie in this interval. So this technique is called confidence interval, and we will also discuss what is the meaning of 95% confidence interval, 99% confidence interval, and so on. So this is the main logic of that means in this technique we will discuss what is point estimation, what is confidence interval, right? The second thing that I want to discuss with you, that is called testing of hypothesis. Okay, testing of hypothesis, in which what we do that we construct a statement. We write our statement and we will prove whether that statement is true or not. So for example, in this, if I consider same example in which we have we will consider that average expenditure of the people or families they are staying in the society will be approximately rupees 20,000. Okay, on monthly basis. So alternative hypothesis can be mu is not equal to 20,000, or mu is greater than equal to 20,000, or mu is less than equal to 20,000. Okay, so now based upon the sample, okay, we got some information and we have some criteria, and we will put the value in the criteria and cross check whether the statement that we have given, that mu is equal to 20,000, is true or false. Okay, that things comes under testing of hypothesis. So I'm going to cover both things as much as possible today. Otherwise, we will have tomorrow session also. Okay, so let me start with the topic estimation. And I already have given you brief that what is estimation, why we do estimation. So if someone has any doubt till this stage, one can ask me. Then I will start the topic. So no one has any doubt. So let me start with the today's presentation. So as already discussed, that in the estimation we have two further segments. One is called point estimation. Second one is called interval estimation or interval estimate. Okay, a point estimate is a single number. Why so? Because when we take is one sample, we put that sample in one function that is called estimator. Okay, so for the testing of mean, we have a function x bar. So what we do, we derive the sample mean. Okay, we got one value, but when you change the sample, your value of x bar keep on changing. So that's why point estimation changes with the change of the sample. So a confidence interval provides additional information about variability. So as already discussed with you, that in the confidence interval, we not only get a single value, we will provide an interval in which we can say that your two population parameters lie. Okay, and the value of this confidence interval depends upon that how much value of alpha. I will also talk about what is alpha, what is type 1 error. So generally we will construct different type of confidence interval. We will construct 95% confidence interval. We will construct 99% confidence interval. The main logic of this term 95% says that we are 95% sure that, or confident that, our true population parameter lie in this range. And what is our true population parameter? That is mean, because we are using sample mean as an estimator to estimate the population parameter mean. Okay, so this thing is, I think, clear to you why we construct confidence interval, because when we keep on changing our sample, so our value of the point estimate keep on changing. So it is better to construct a lower and upper interval. So that helps us to say that that two population parameter lie in this range. Okay. So we have example, like we will consider two parameters, mu and p. So mu is a parameter of mean for the normal distribution, and we know that to estimate this mu, we have a function of sample observation that is called x bar. It is also called sample mean. Okay, and I think all of you have heard about term proportion. And can you explain me what do you mean by proportion? Anyone? Okay, you can also put your answer in the chat. I will respond on the chat also. Okay, so let me tell you, if you're not aware about term point proportion. So let us suppose, so we are dealing with a data set in which we have information given to us that among 100 persons, there are 45% or 55% they are affected with a particular kind of disease. Okay, or so that you can say that, so there are 45%, those are not affected with the disease. So proportion that, what is the proportion that how many persons are affected with the disease? 0.55. I think this idea is clear to all of you. So it is basically you can think about how it shows that proportion on a percentage thing that how much percentage persons are affected. So basically proportion is derived in such a manner that shows the value in terms of percentage. Okay, so we know that if you want to find the sample analog of proportion, so we have a formula that is called mean of the sample. So these things are relevant if you do some testing. That means we further do some testing. In that case, we will discuss about the examples. So as already discussed with you, what is the meaning of confidence interval? Because we have uncertainty of the parameter in the point estimate. So what we do is we construct a interval that consists of the population parameter, two population parameter, and these intervals are called confidence interval. Okay, as already explained to you. Okay, so what this interval consists of? It consists of a variation in the sample statistics from sample to sample, and it is not it is based on one sample, but we will say that with such confidence our true population parameter lie in this range. Okay, so this is one example I want to say here is, so we have a population here, okay, in which we do not know the population parameter mean. So mu is basically used to represent the population parameter mean. Okay, and what we do is we will take one sample, and from the sample we got an idea that the population mean is equal to the sample mean is equal to 50. Yes or no? Okay, so now whether we can make a statement, whether we can say that I am 95% confident that mu is between 40 and 60, how one can get that? So for that we have a mathematical expression. Let me give you some brief about that. So how you can derive this? So we first write our expression in this mathematical form. So where x bar is the point estimator, okay, T alpha by 2 is the distribution. So we have not discussed what is the distribution, but we have different critical points here. So that depends upon the information or assumptions that we have given in the data set. So based upon this condition, because parameter is unknown to me, sigma square is unknown to me, in that case I will go with the T distribution, and this is the critical point for that. And S by square root of n is the formula for the standard error. So general formula, you can say that estimator function plus minus critical point into standard error. So when you put the information in this expression, there is plus symbol, this is negative sign here. So when you add something in the estimator, you will get the upper bound. When you subtract something from the estimator, you will get the lower interval. So based upon that, one can derive the confidence interval. So we have further few examples. So we already have discussed that the point estimation plus minus critical value and standard error. So this is the general way to write down the formula for the confidence interval. Okay. So now you have to think about what confidence interval consists of. So it consists of the range for the unknown parameter. That means in which we are interested. So if we are interested in the population parameter mu, so it will consist of the lower and upper limit for that parameter. Okay. And how to construct confidence interval? So we have a formula that is called 1 minus alpha. And have you heard about the term alpha before? Anyone? Have you heard about term type 1 error, type 2 error? Okay. So if you're not aware about, let me tell you. So type 1 and type 2 error. Okay. So let us suppose, as already we have given one statement that if I am assuming that mean expenditure of a families, those are living in the society, is 20,000. This is my statement that is given from my side, right? My assumption, yes. And the second assumption is it is not equal to 20,000. Okay. So reality. So I am writing now reality above in the table. So if actually the value is 20,000, that means they are spending 20,000 on on a monthly basis. And okay, so in reality, the possibility can be that it can be equal to 20,000 or it cannot be equal to 20,000, right? So my assumption is that the mean expenditure of the household, those are living in the society, that is equal to 20,000. And on the reality basis, if it is actually 20,000, that means I am making a good statement. All of you agree with me? Yes or no? Okay, if you have covered yesterday, then it is fine. I'm not going to repeat again. So just let me wind up soon. Okay, so if that's my statement that is mu is equal to 20,000, okay, I am saying that it is true. Okay, but actually the mu is not equal to 20,000. So what I'm going to do, whether I'm going to make a type 1 error or type 2 error, can anybody can tell me? That will be type 2 error. Because I am saying that mu is equal to 20,000, but actually is not equal to 20,000. So it means I am accepting my null hypothesis, whether in that case my null hypothesis is not correct. Okay, and H1 is true. So in that case, I'm committing type 2 error. So if I'm saying that my assumption says that mu is not equal to 20,000, but actually mu is equal to 20,000, so that means I am committing type 1 error. And in that case, when mu is not equal to 20,000, this is my assumption, and actually it is not equal to 20,000, that means I am doing a correct decision. So hope the idea of type 1 error should be clear to all of you. So when we take the probability of type 1 error, okay, so whatever the value we get, that is called alpha. Okay, so we want our type 1 error or type 2 error, both should be minimum as much as possible. But there is an inverse relationship between alpha and beta. Okay, so that's if you're going to suppress, that means if you want to reduce type 1 error, so type 2 error will increase. Okay, so I'm not going to tell the depth of that, but I have just explained to you the meaning. So generally we assume alpha is 5%. 5% means, so we are assuming that 5% the chances are there that sometime we reject our null hypothesis when H not is true. Okay, that means whatever the statement that we have made and the null hypothesis, we are rejecting that statement, but on reality the statement is correct. Okay, so now you can see that when we put alpha as 5%, so we got a confidence interval of 95%, because when you subtract 5% from 1, you will get 95%. Okay, so we can say that we are 95% sure that true population parameter lie in this range. Clear? So we can see that how confidence interval is further segmented into two further segments. One is called population mean and population proportion. In the population mean, we will try to find the confidence interval for the parameter mu. In the population proportion, we will try to find out the confidence interval for the population parameter p. So there are further two segments. One is called sigma is known or sigma is unknown. As already discussed with you, that based upon the information or assumptions, we will write the expression for the confidence interval for the parameter mu. So when the sigma is known to me, the form for the confidence interval for the parameter, that means confidence interval for the parameter mu is x bar plus z alpha by 2 sigma upon r. So what is z alpha by 2? Can anybody explain me? Z alpha by 2 is a critical value that comes from the standard normal distribution. Okay, and alpha by 2 will be the, why we are taking alpha by 2? I think if you have covered this topic yesterday, then you can explain this thing. Okay, so we are saying 1 minus alpha %. So it means 95%. So what we are trying to say, because we are dealing with two-sided cases. Two-sided means we will reduce 2.5% on the left-hand side. We will reduce 2.5% right-hand side, extreme values. So remaining part will be 95%. Agree with me? Okay, so here Z alpha by 2 is that critical point that segregates this part from this remaining part. Minus Z alpha by 2 and Z alpha by 2. So that's why we have Z alpha by 2. And sigma upon √10 10 is the expression for the standard error when the sigma is known to us. Okay, so when you put the value in this expression, you will get the confidence interval for the population parameter. Okay, so there is one example that will help you to understand the logic. So we want to construct 95 confidence interval when the parameter sigma is known to me. So as already explained to you that we have this region as a 95% 95% covered area of the standard normal distribution, and this two left hand part and right hand part that shows the 22.5% on both sides. So this is called lower confidence limit. This is called upper confidence limit. This is our point estimate. Okay, and point estimate keep on changing. That's why we are trying to find our confidence. Okay, the idea is clear to all of you. And when you can see the value of Z alpha by 2, when alpha is 5%, it is 1.96. So this value will remain fixed. Okay, for alpha is equal to 5%. So whenever we have to construct confidence interval, when the sigma is known to us, population, the standard deviation is known to us, we have to just put the values in this expression and you will get the answer. The idea is clear to all of you why we need confidence interval. And similarly, we have various values for Z alpha by 2 for different confidence interval, 90% confidence interval, 95% confidence interval, 99% confidence. Okay, 90% confidence interval says that we are 90% sure that our true population parameter lie in this range. 95 says that we are 95% confident our true population parameter lie in this range. And 99 means we are 99% sure that our true population parameter lie in this. Okay, so now there is one question from my side to all of you. So you can see that your critical points keeps on increasing with the increase in the confidence interval. So whether they have wider width or shorter width, when we have, let us suppose if you take 90% confidence interval or if you take 99% confidence interval, which one has wider width? And I think all of you are able to understand the definition of width here. So which one has higher interval width, you can say? Can anybody answer this question? So if you participate, then only I can understand whether you are we are on the same page or not. Okay, so 99% good. Ishaq has. Okay, good. So I think the reason is clear to all of you, because when we talk about 99% confident confident interval, so the critical value is higher. So we subtract or add more as compared to 90% confident. Okay, that increase the width of the whole class interval. All right. So you can easily see that when we talk about the sampling distribution of the mean. Okay, so we can, the thing that I want to convey that is easily be seen from this graph, that when we take one sample, we got mean here, we will take another sample, we got mean here, and so on. Our mean keeps on changing because it can't be remain same when we change the samples. Okay, so what we can do is we can construct the confidence intervals by using the formula that I already explained to you. This is the lower limit, this is upper limit. So whatever the value of alpha we will choose, based upon that we can make our statement that how much confidence interval we have constructed. Okay, so have you heard about the margin of error before? So basically you can easily see the amount added and subtracted the point estimate to form the confidence interval. So whatever the we are adding or subtracting, that is called margin of error, or sometimes it is also written as interval width. Okay, two times of this margin of error is also called interval width. So margin of error will be just the expression that we are adding or subtracting from the estimator. Okay, so what are the factors that affect the margin of error? So you can easily see margin of error depends on these expression, that Z alpha by 2, sigma, and under root of n. So when sigma increased or decreased, your margin of error increase or decrease simultaneously. So when your sample size increased, your margin of error decreased. Obviously, when the denominator value is increasing, so it reduced the margin of error. So when your confidence interval decreased, your margin of error also decreased. The reason is, so like we have already discussed that for the 90% confidence interval of a Z alpha by 2 value was 1.645. For 99, it was 3.25. So it means when you multiply with the lower confidence interval, the value was 1.645, that automatically error term will be reduced. Okay. Okay. So we have one example. So the example says that a sample of 11 circuits from a large normal population has a mean resistance of 2.2. So we know from past testing that the population standardization was given as 0.35 OHMS. So what is given to us? Sample size is given as 11. So why I have these examples because so you can understand how to construct the confidence interval. So n is equal to 11 here. The mean residence, okay, population has a mean residence of 2.2. And we know from the past testing that the population standardization is 0.35. So how one can construct the confidence interval? We just have to put the values in the formula. The formula says x bar plus minus z alpha by 2 sigma upon under 10. This was the formula. So we got sample mean as 2.20, z alpha by 2 as 1.96 because it is already fixed for 5% confidence interval. And we got the value sigma as 0.35. After putting, I got the lower and upper interval in this one. So this is one simple example that helps to understand. So now you can see that what's the interpretation we got. So interpretation says that we are 95% confident that our true population parameter lie in the range of this 1.9932 and 2.4086. Okay. So now we are going to discuss about what is the formula for the confidence interval when the population parameter sigma is unknown. So there's only one change you have to see that when the sigma is unknown, we have to estimate sigma from the sample observation. What is sigma? That is standard deviation. Population, you can say standard deviation. Now we have to estimate with the sample standard deviation. So in that case, our distribution will be changed. That critical value distribution will be changed. So we will use t distribution. So they will be changed in the mathematical form. The mathematical change form was x bar plus minus t alpha by 2 s upon square root of n. Okay, so we will change z alpha by 2 with the t alpha by 2. And there is one more term that is called n minus 1, degree of freedom. Because t distribution, when you see the t distribution table, they also ask you with the degree of freedom. That was not a thing that is given in the Z standard normal table. So we first see that how many observations we have. So in the previous example, let us suppose we have n as 11. So we will see the value of t alpha by 2 at value 10 first. Then we will get the value for the t alpha by 2. That is, if alpha is 5%, that is 2.5% t at value 10. Okay, and when you put this thing, you will get the value for the confidence interval. So there is one example you can see. So we can see that in the example, suppose the mean of 3 numbers is 8. So we have the information that 3 number has mean 8, but we have only information that the first observation mean is 7 and the second observation mean is 8. So we can derive the mean for the third observation. That is not a problem for us. Okay. So now, because there is no information regarding the standard population variance, so we can estimate from the sample observation, and we put the values in this formula and we get the confidence interval. Okay, and there's one more important property. Maybe you are aware about this property, that the t distribution has the same curve like the normal distribution, and it is also said that when the sample size increase, then the t distribution converges to the this normal distribution. So you can easily see that these two distributions, these two curves, if they are coming from the t distribution with these degree of freedom. Okay, degree of freedom shows that how much observations we have. So in this, we have 6 observation in the sample. Here we have 14 observation in the sample. So when they keep on increasing, okay, then the shape of the t distribution will converge to the normal distribution. This idea is clear, and you can also observe in real life sometime that for the large sample size, so we generally put a cutoff that when we have more than 25 number of observation, or when we have more than 30 number of observation, so people generally say that do not check the assumption of normality of data, just implement the test, jet test and other things, because they generally assume that for large sample size we can directly implement jet test. Okay, so and for my this is one suggestion from my side, that although you have more than 30 observation, but at least you have to once check the normality of the data set or not, because sometimes it is not always the case that for large sample size your data converges to normal distribution. You have to check the normality of the data set first, and based upon that you have to choose whether to implement parametric or non-parametric test, right? So this is one example of student table in which you can see that if you want to write the value corresponding to 2.5% or 25%, 10% corresponding to the degree of freedom, you can see those values. Okay. Here we are getting that upper tail in the case of alpha is equal to 10%. Okay, in that case, alpha by 2 will be 5%. And you have to see the column corresponding to 5%, and correspondingly you have to see how much degree of freedom we have in the for the T. Based upon that, you have to choose the cell. Okay, this will be the value of the critical point. This is another example in which we have different confidence interval, and we derive we can see the value for the T corresponding to 10 degree of freedom, 20 degree of freedom, 30 degree of freedom, and so on. Okay,
Sir,
because
there is one question in the chat box. Please check it.
okay, let me see. P form for which degree of freedom we could say it is almost P form. So I'm not able to understand the P form meaning. P form. So generally, so you can write the query. So what I'm trying to say, so for large sample size, it can be.
Ellen, you can unmute your mic.
Thank you very much. I would like just to ask when we could say in reality, of course, that degrees of freedom are almost infinite.
Basically,
so when
this is theoretically assumption that for large sample size, so there is no specific. We are not saying that it is equal to infinity. It is approaching to infinity. It can be 10,000, can be 1 lakh. So basic thing you have to understand here is that we have to see that at what for which sample size the properties of the T distribution should be equivalent to the normal distribution.
Okay, many
that
thanks.
varies from one study to another study. Are you getting my point? So let us suppose if I am doing a study on patients, right, that those are diagnosed with a particular kind of disease. As simultaneously, I'm studying on one example that I just discussed with you, that I want to study the mean expenditure of households. So if there is a significant difference in the variation that is present in the data, so for that I can't put a single value that for both cases n is if equal to 500, then it approaches a normal distribution. So it is different for both cases. Okay, and we have to check also that how much large, how many observations we need so that the properties of the T distribution converge to the normal distribution. Hope the idea is clear to all of you. Are you able to understand this this thing, right? So there is no any specific cut point that we can say that this cut point has achieved now. So now our property of the T distribution converge is equivalent to the normal distribution. We have to test it. We have to check that. So whatever the assumptions, whatever the properties that one normal distribution has, whether our data set now got such properties now, or still it deviates from those properties. So till that time, we have to make a statement that our distribution is non-normal or normal. Okay. So one example that I want to discuss here is, so now we have example that in which we consider a sample of size 25, in which X bar is given as 50 as standard deviation, because S is written, so it means we do not have the true value for the population parameter sigma. That means it is unknown to us, so we estimate the sigma with the sample standard deviation. So it is given as 8. So in that case, if we want to construct the confidence interval, so what we need, we have to see that we have a sample of size 25. So degree of freedom is 24 here because we reduce 1 degree of freedom for the normals from this from the sample size. Okay, so we got 24 degree of freedom, and T alpha by 2 will be, because we have 95 confidence interval, so it is alpha is equal to 5%. So alpha by 2 will be 2.5%, right? And we will see this value from the table. Okay, so we just put the values of X bar 50 plus minus 2.0639 and S upon 110. S is the S value of has value 8, and N has value 25. So we got a confidence interval as 46.698 and low value as 46.698 and upper value is 53.302. Okay, so what we got? We got 95% confidence interval for the parameter mu. So we can say that we are 95% confident that our two population parameter mu lie in this range. Okay, so there is one thing already written that. So we are not saying that with probability, we only say confidence. That's why it is called confidence interval. It is not probability interval. So the name is confidence. We can say with confidence, not exactly we can say that it is equal to 95%. Okay. Okay, so there is a criteria that I already discussed with you that when T approaches Z at a sample size increases, an approximation is sometimes used when N is equal to greater than equal to 30. So that's why I'm saying that. So this is generally sometimes an assumption that for N greater than equal to 30, so most of the properties of the T distribution converge to the normal distribution. But again, I'm saying we have to again cross check. Okay, whether it fulfill the criteria. If it did not fulfill the criteria, then we will go with the t-test. Okay, then we go with this formula. So that's why they are saying approximating for large N. So there is no such condition that they have put here that N should be equal to this one, then we got this property. So it varies from one case to another case. So now you can see both the formulas. So here it is sigma by mistake. It is okay. Why they have put his S here? Because they are replacing T alpha by 2 with Z alpha by 2. Okay, although the sigma is unknown to us, but they are saying that on approximate basis, we can replace T alpha by 2 with the Z alpha by 2. In that case, both the interval values should be close to each other, but they are not equivalent. Okay, there must be difference in the decimal places. Okay, so all of you have very much faced a problem that how to determine the sample size. I think if you are doing some studies in medical sciences, so most of the people, they used to ask me how to determine the sample size. What should be the sample size for my study? Okay, so I asked them a few questions. The first question is how much margin of error or how much alpha, this probability of type 1 error or level of significance they are assuming for this study. How much accuracy they are assuming for this study. Based upon that, one can determine the sample size. So the formula, what is the formula here? You can easily see. So if we have the value of the margin of error, we already have discussed what is the definition for margin of error. If we have the value of margin of error, if we have the value for the confidence interval, based upon that, we get the value for the alpha. And we determine the, based upon the value of alpha, we can determine the value for the this critical value. So if sigma square value is known to us, that is very good thing. Otherwise, we can approximate it from the sample. Or if sample is not available to us, we can also assume it as 1 to 0.5. Based upon the previous studies, recommendation of previous studies, we can use those values. And based upon that, we can determine the sample size. This thing is applicable only for a single study, not for the, when we are doing any case and control study. For that, we have different formula. So this can be only be applicable when we want to conduct a single, we want to take only single sample from the population, and we are not comparing it with the other one. So this thing, I'm going to make it clear at this stage only. So for the two sample, for the two, means when we have case and control studies and other studies, so the formula for the determination of the sample size is different. Okay, so let's take one example. So it is given that the standard deviation of the population parameter is given as 45. So what is the sample size is needed to be 90% confident that we are that margin of error is plus minus 5. Okay, this is clear. So we, based upon the 90% confident interval, we got value of alpha as 10%, alpha as 2 as 5%. So we see from the table that we have just gone through that in the 90% confident interval, the Z value was 1.645. This one, right? And we put that value in this formula. (1.645). Sigma value is already given to me, 45. Then we have value for error term, that is plus minus 5. When you put all these values in this formula, so we got a sample size of 2.9. So it means to conduct a study in which we want 90% confidence and we want plus minus 5 error term, and when sigma is given as 45. So for that we need 22 or 220 sample size. Okay, that means we will collect responses from 220 observations or persons. So now what will happen when sigma is unknown? As already discussed with you, we estimated from the sample. So in that formula, we replace this sigma with the S. Okay, so hope the topic of point estimation is clear to all of you, in which we have discussed about in the estimation, we have discussed point estimation and confidence interval. So if someone has any query, one can ask, because the topic that I'm going to discuss further, hypothesis testing, that is entirely different. So earlier we estimate the value from the sample. Now we make a statement and test it whether that statement is true or false. So if someone has any query, one can ask. Then I will continue further. Anyone?
Good evening, sir. I have a
Good
small query.
Yes, yes.
Yeah, I'm Dr. B. Baswanlik. Sir, I just want to know that, as you said, that when sigma is unknown, you are approximating the statistic by the sample variance. So, won't that lead to an error? I mean, let's say when we are actually knowing the sigma from the population, and when we are approaching sigma by S, okay, from the sample, so that might lead to a little bit of error, as
So
far as
that-
I think.
Yes, sir.
Or
So
how-
that point
how
is
do we get rid of this?
yeah. So let me I got the query. So basically what I'm trying to say, so when something is unknown to us, so either
Yes.
we approximate from the previous studies,
Okay,
right, similar studies that already exist in the literature, or either what we can do is we do some pilot study, and based upon that we derive some estimate, and we use that estimate to find out the sample.
okay, okay. So based on some previous studies on that
Yeah.
particular sample, we need to estimate the sample standard deviation.
Yeah, the reason is because if we are going to make, so let us suppose in this formula we need the value of sigma, right?
Yes, yes, yes. But sigma is
so
not
how
known.
so if it is not known, then how we will get some estimate? So either we,
Right.
so basically it also happens that, so let us suppose, so once we have taken sigma as some value, but
Yeah.
we got value of n very large or small, so we can see that how people has done similar kind of study. Similar kind of studies means, so let us suppose you're doing a study for one
Yes.
drug A, right? So you can
Right.
also see that how people has conducted similar kind of study for drug B.
Right.
Okay, and based upon that, you can see that they have considered sigma as this thing. So you can see that if we take more value of sigma compared to that,
Yeah.
or less value of sigma, how your sample size varies. And based upon that, you can make your final decision.
Okay, okay, okay. So we need to make some comparative study based on the past results.
Yes, yes.
And then we
So,
have to
so
decide on that.
basically, no studies complete by itself. We have to see from the literature also that how people has conducted similar kind of study in the past. Okay,
Right,
because
right.
okay, because if we are doing some, if we are collecting responses from the audience or from respondent, so it is very costly thing, no? So because if we are
Yeah.
dealing with patients, so it is not very easy to gain more patient. It means to increase the patient sample or reduce the sample of the patients.
Right. Yes, yes.
So that's why we have to so lot of paperwork should be done before finalizing the sample size. This is my suggestion to all of you.
Okay, sir. Thank you, sir. Thank you so much.
Thank you.
Thank you, sir.
So any other query from the audience? Okay, so I'm going to start a different topic, although it comes under the inferential statistics also. So here, what we are covering today, that we start with a one sample problem. One sample problem means that we take one sample in which, for example, I was already discussed with you that I want to make a statement regarding the expenditure of the households, those are living in a particular society. So this is one sample. Okay, and whatever the statement I am going to make, that the mean value is equal to 20,000. So this is noted as mu naught. That means the value that assigned from my side. Okay, so I want to test this statement. So two sample here means, so let us suppose I have two societies. They are living in the front of each other. That means there are two societies front of each other. In the first society, there are 500 persons. In the second society, there are 450 persons or 600 persons. And we want to compare their mean expenditure. So now in that case, I will make comparison of mu1 is equal to mu2. Okay, hope the idea is clear to all of you. So I'm going to write it again. So in the first study, in the one sample, so mu naught here is I am giving value from my side, and alternative one is mu is not equal to mu2, or it can be greater than mu2 or mu naught, or it can be less than mu. Okay. The second one is mu1 is equal to mu2. Alternative one is mu1 is not equal to mu2. Mu1 is greater than mu2, or mu1 is less than mu. So here, what I am trying to say that here I am comparing the mean of one group with the other one. Okay, and alternative one can be not equal to greater than less than. So, but here I have only one sample. I am just giving my guesses that what can be the possible mean of that group. Okay, so this thing comes under all these things that I am discussing with you. I am discussing under the case of parametric. Okay, parametric, I think this term, have you heard about parametric and non-parametric? Okay, let me give you some brief about that. So whatever the case we are discussing today, in which we are assuming population parameters. Okay, so generally when we have some data set, that means we collect some data set, we generally assume that that data set follows some distribution, right? If that data set doesn't follow any distribution, so whatever the technique, whatever the methods we are discussing, that cannot be implemented over there. So for that, we go with a non-parametric approach. Okay, in which we not comparing the means, we will compare the medians and other parameters and other you can say functions. You can say, okay, it can be scale, it can be median, but it can't be mean. So there is a very major thing you have to keep in mind, that whether the distribution of the data set is defined, completely defined, and if it follows normal distribution, so we can adopt the following approach that I'm going to discuss today. If it doesn't follow normal distribution, then we have to go for the non-parametric approaches. Okay, that will take more time, so I have not incorporated those things. So I just want to cover today in by today's session, tomorrow's session, only the approach that comes under normal distribution of parametric. Okay. So in that, if you have any query, you can ask, right? So what is hypothesis? As already defined to you, that in which we are just making a claim assumption from our side regarding the population parameter. So what are the population parameters? So if we assume that our population for a normal distribution, so it consists of two parameters, mu and sigma square, where mu represents a mean and sigma square represents a variance. So either the statement can be only for mu, or it can be for variance also. Okay, clear? So in both the cases, we put parameters, population parameters in the statements. Okay, so there is one example you can see. The mean monthly cell phone bills of the city is equal to $42. So what they are trying to say, so they are giving one statement: the mean monthly cell phone bills of the city is given as, mean value is given as $42. So it means we are saying that on average in that particular city, the expenditure is given as $42. So this is one statement. So we have to cross check whether this mean is not equal to 42. It can be greater than 42, or it can be less than 40. Okay. So this is our null hypothesis. Okay. Similarly, proportions of adult in the city with cell phone is 68%. So what they are trying to say, that in the city, 60% adults, they are having cell phones. 68%. So we are just making a statement, and based upon the sample, we will conclude that whether the statement is correct or incorrect. Okay. So whatever statement we give, that is called null hypothesis. Okay. And generally what, so let me clear this thing, because sometimes when most of the researchers, they used to come to me, they say that we define a statement that we want to prove that our drug is significant. So that is your alternative hypothesis statement. The reason is why, because when we talk about null hypothesis, we always want that the statement should be normal. Normal means here is that there is no impact of, that is, the your drug is non-significant, that is your null hypothesis, and your drug is significant, that is your alternative hypothesis. Because from the sample we want to prove that your null hypothesis got rejected, it automatically means that we want that your alternative hypothesis got accepted. I think this point is clear to all of you, and this is a very important point. And when most of the students, they used to come to me and say that, so they have already defined a statement, so whether we should consider this statement as a null hypothesis or alternative hypothesis. So whatever the research statement they used to generally construct, that is for alternative hypothesis. Okay, so null hypothesis, in which we always expect that there is no significant difference between these two drugs. We always expect that there is no significant impact of introducing new drugs, so that all these statements comes under null hypothesis. I think the idea is clear to all of you. Okay, so there is one assumption that the average number of TV sets in the US home is at least 3. So one thing I want to make it clear that in the null hypothesis we can use. Okay. In the null hypothesis, for example, I am a doctor, right? So I got some query from Ishaq. So I am a doctor. So I'm you can say, I'm a doctor. I want to construct new drug for a disease like disease A. So, but I'm trying to make a claim that my drug will help to reduce the negative impact of disease in the patients. This statement is clear to all of you. So in that case, I will make another hypothesis that there is no significant improvement while using my drug in the health condition of patients. And alternative hypothesis is that my drug is significantly work and it improves the health conditions of the patient. So this is clear, Mr. Ishaq. I think you have asked this question. Or should I repeat it again? Okay. So in the null hypothesis, you can easily see, so I already discussed with you that equality symbol should be there, but we are not always saying that equality symbol cannot consist of greater than less than symbol. So here we are making a statement that the average number of TV sets in US home is at least 3. So if you are saying at least 3, so alternative hypothesis is opposite of that. So opposite, but is opposite of this statement is mu is less than 3. Okay, so this is your alternative hypothesis. So based upon the sample, if we got such results that this null hypothesis is incorrect, so automatically we can say that your alternative hypothesis. Okay, and it will only consist of population parameter, as already discussed with you. So we are not talking about a sample. So what is the null hypothesis? We began with the assumption that the null hypothesis is true, similar to the notion of innocent until proven guilty. So this is the statement that we can easily see from the judgment. Okay, so we consider a person innocent until we get some information that the person, we get some evidence against the person that the person has committed some mistake, and we prove that person as a guilty. Okay, so it consists of equal to symbol, as already discussed, less than equal to, and greater than equal to. So equality sign should be there. Okay, and it may or may not be rejected. And now come to the opposite of alternative null hypothesis, that is called alternative hypothesis. In the alternative hypothesis, you can see that because we have defined null hypothesis as mu is greater than equal to 3, so alternative should be opposite of that, so it consists of less than 3, right? So here you can also see that in the alternative hypothesis, equality symbol should not be there, less than equal to, greater than equal to not be there. So it will consist of not equal to, greater than, or less than. Okay. So there is one example. So we have a null hypothesis that the mean age of the population is 50. This is one assumption. Now, based upon the sample, we will try to prove or disprove our statement whether this statement is true or false. So we have taken a sample of persons, and we got some idea that on the sample observation we got mean age of the sample is 20. So we are making a claim that it is 50. So whether that statement is true or not. So obviously, although we have the criteria, but obviously one can see that. So there is a very large deviation in the statement that we have made and the output we got from the sample. Okay, so we are going to reject the null hypothesis directly. Okay, and this is the reason I already explained to you that when the value lie on the extreme points, either this side or this side. Okay, so and if it is lying on the rejection region also, this is the rejection in on the right hand side, this is the rejection region on the left hand side. So we reject the null hypothesis. And in which level of significance is plays very important, because we determine these critical points that we have on the left hand side or right hand side based upon the value of alpha. And alpha is basically the probability of type 1 error. Okay, so we have value, most commonly used values of alphas are 1%, 5%, 10%. 1%, 5%, 10%, right? So level of significance. So now we are going to complete the same example that we have discussed above, that in which we have assumed that the average sets of TV in the households of US is greater than equal at least 3. So alternative is less than 3. So we are only testing on the lower test. This is called one-side test. Okay, because we have to test only on the one side, on the left hand side. And if we have opposite statement, that if whether we have to test alternative hypothesis greater than 3, then we have to test only on the right side. And when the not equality symbol is there in the alternative one, so we have to test on the both sides. So our critical reason will be on the both sides. So this is called two-tier test. And alpha by 2 will be on the right hand side as well as on the left hand side. Okay, this is very important thing one has to keep in mind, whether we are doing one-sided test, and one-sided we are doing left tail test or right upper tail test or two-tail test. Okay, so I already have explained to you the meaning of type 1 error. Type 1 error means probability, that means the chances that we are rejecting the null hypothesis when null hypothesis is actually true. Okay, so the probability of type 1 error is defined as alpha, and it is also called level of significance. Okay, so now what is type 2 error? When we accept the null hypothesis when our alternative hypothesis is true. Okay, fail to reject a false null hypothesis. Fail to reject means our null hypothesis false, but we are accepting it. So that is called type 2 error. And the probability of type 2 error is called beta. And 1 minus beta is called power. I think you have discussed yesterday, I don't know. Okay, so now this is the table that I already discussed with you, in which decision and state of nature. Decision, do not reject H0. This is the decision I'm making. And actually what happened is our H0 is true and we are not rejecting. So we are not doing any mistake. So this is a correct decision. Okay. Similarly, when the decision is do not reject H0 when H0 is false. So we are making a type error. That is called beta. Probability of that one is called beta. Okay, and reject H0 when H0 is true. So we are making a type 1 error. We are committing a mistake. Okay, and when we are rejecting H0 or actually H0 is false, we are doing a right decision. Okay, clear? So as already discussed above that, so there is a relationship exists between probability of type 1 and type 2. So type 1 error can only occur if H0 is true. Why? So because type 1 error means that we are rejecting H0 when H0 is true. So H0 should be true, then only type 1 error will occur. So H0 is false means when we are saying that when we are saying our H0 is true, but actually it is false. So that's why we are making type 2 error. So you can see when we try to reduce the type 2 error, then your type 1 error will increase. Or you can also say that when you increase the type 1 error, your type 2 error will increase. So there's a vice versa relationship but exists between alpha and beta. Okay. So when we keep the sample size fixed, we keep other things fixed. So when you increase the type 2 error, your alpha, that is probability of type 1 error, will reduce. When you increase the value of beta, that means type 2 error, your variance also increased. And when you increase the type 2 error, probability of type 2 error, your sample size will reduce. Or you can also say that when you have a sample size, less sample size, your beta will increase, sigma increase leads to beta increase. If alpha decrease, your beta increase. Both way you can see. So I think why I have discussed these things, let me tell you the reason behind that. Because generally, when we deals with the data, so there is always a question that what should be the value of alpha. So let me tell you two examples. So alpha can be 5%, alpha can be 1%. So why we consider very small value of alpha in the medical sciences? Can anybody answer this question? Okay, let me give you this answer. So for example, I am developing a new drug. Hello.
Yes, we take the value of alpha small in order to keep the probability of type 1 error small, because if you increase the probability of type 1 error, then actually the error will be more in the hypothesis testing, as far as I think. So naturally it should be taken 0.05 or 0.01.
Yeah.
Yeah, 5%.
So basically, yeah, good sir. So basically, I want to add something in that. So when we talk about very small value of alpha in the medical sciences, the reason is that because we are dealing with human beings, right? So if we are saying that whatever the drug we are going to introduce in the market, so we want error should be as minimum as possible. Agree with me? Okay. So let us suppose if I am considering if I am developing a new product for, you can say, like let us suppose I'm developing a computer, I'm developing a chair, right? So in that case, if I consider 5% level of alpha, 10% level of alpha, that doesn't directly impact the human life. Although we are using these furnitures and other equipment for our convenience, for our requirement, but that doesn't directly impact the life of human beings. So for to control that, there should not be any you can say bad effect of medicine that is launched by any company. So we keep the error as small as possible. Okay, so that's why we consider very less value of alpha. That means 1%, 0.0, something like that in the medical sector. Okay. So now, so approach of testing. So as already discussed with you, there will be again two test statistics. One is based upon the information that is given to us. If sigma is unknown or known, based upon that, we have a different form of test statistics. And how we will going to make a statement about the acceptance or rejection of the null hypothesis. Let me explain it to you. So what we do, we construct a function. So I am saying function that is called test statistics in literature. Okay, so I put the values of sample observation in this function. Okay, then I compare the value of this test statistics or function with the tabulated value. That depends on how whether the parameters are known or unknown to me. So now what is the tabulated value here? Tabulated value means, so first I know the distribution of the test statistics. And when I got the information that this is the distribution of test statistics, I see the value from the table. That is called tabulated value, corresponding to the degree of freedom or alpha that is defined in the problem. And if the value of test statistics is greater than the tabulated value, or mod of the function is greater than the tabulated value for two-sided test, then I reject the null hypothesis. So we will do one or two examples that will be more convenient for you. So this is one example that is for one-sided test, that is low tail test, in which we want to test whether the mu is greater than or equal to 3. And what is the mu? That represents the average TV sets available in the US house. Okay, so we are doing on the left-hand side testing. Okay, and what I need the sample value. So okay, if I'm assuming that sample value is coming as something 2. Okay, so what I do is I put this expression x bar minus mu upon sigma upon undo 10. Although this will be explained in the next slide, so I am writing it here. So now is because I am putting sigma here because sigma is given to me. This is my assumption. If sigma is not given to me, then I have to estimate with the sample standard deviation. And if I estimate my this sigma by the standard deviation, then this distribution of this function changed from z to t distribution with n-1 degree of freedom. So now what I am going to do is I got the value of X bar from the sample. I got the value of mu from the null hypothesis. I got the value of S from the sample. I got the value of N from the that how many samples I have taken. So now I will compare this function with the tabulated value, okay, with alpha only, because I am doing only one-sided test. So if the value of this function is greater than the tabulatory value, then I reject the null hypothesis. Otherwise, do not reject the null hypothesis. I think this statement is clear to all of you. Okay, and you can also see that if the value of sigma is given to me, so I will write down this expression in this manner. Okay, and I tell you that this expression has come from this expression. Okay, so let us suppose I am saying that X bar minus mu sigma upon 110 follow normal distribution. So I am saying this has some critical value Z alpha by Z alpha, because we are doing one-sided test. So when I multiply this expression, so this will become X minus mu Z alpha sigma upon 110. So when I take mu on right hand side, this will be mu plus Z alpha by 2 sigma upon 110. This is the upper side, upper tail, but I want lower tail, so I put minus here. So this will become mu minus Z alpha by 2 sigma upon. It's the same expression I got. Hope this thing is clear to all of you. For the upper tail, we will see on the right hand side. For the lower tail, we will see on the left hand side. And for that, we will take the critical value negative. And for the upper tail, we will take the critical value as positive. Okay. For the two-sided test, so now we will test on the both sides, and we will take critical values on at level alpha by 2, because we will see 2.5%, we will consider 2.5% rejection region on the left hand side, 2.5% rejection region on the right hand side. Okay, clear? Okay. So let's do one example. Okay, so this example says that we want to test the mean. Okay, and the sigma is given to me. So in that case, the form of the test statistic is this one. And we compare this value of this Z with the tabulated value. So if the mod of Z for the two-side test, the mod of Z is greater than the tabulated value Z alpha by 2. Okay, then we reject the null hypothesis. So see the example. Let's see. Yeah. So we again come to the same example, in which we have a null hypothesis. That means in which US home has at least 3 TV sets. So our null hypothesis will be mu greater than 3, and alternative will be mu is less than 3. And sigma is already given to me as 0.8, and alpha we have considered as 5%. Yeah. Now, how we are going to make a statement whether we are going to accept or reject the null hypothesis? So we reject the null hypothesis if the value that we derived from the test statistics is less than minus 1.605. And how we got the value of minus 1.605? Because we have alpha is 5%. So we will see from the table that what is the value of Z 0.05. Okay, and it is coming as minus 1.605. Okay, clear? So now what we are doing, we are putting the value of X bar that we got from the sample, in which we have considered 100 observations. The sample mean was 2.84, and the hypothesis we consider as mu is greater than or equal to 3. We put 3 here. We put the value of sigma that is given to us in the equation 0.8. We put the value of 100. When we solve it, we got answer as minus 2.0. So minus 2.0 is less than minus 1.645 because it lies on this side. Agree with me? When we go negative, so we have more negative value on the left hand side. Okay, so minus 2 should be lie here. So that lies in the rejection region. So we have made that is incorrect. So we reject the null hypothesis. Automatically, we can say that in the US home there is the statement is incorrect that they have at least 3 TV sets. Okay, that is incorrect. So the correct statement is that they have less than 3 TV sets in them. Idea is clear to all of you or not? Okay. So how many of you have heard about the term p-value? And anyone can explain the term p-value? Hello. Have you heard about the term p-value before? Let me know. Otherwise, I will explain. Okay, let me explain to you. So now, till the stage, what we are doing, we are first solving the test statistics function, and then we are comparing the test statistics function with the tabulated value of the distribution. Agree with me? So we have done two examples. That means one example in which we are assuming our data set follow normal distribution when sigma is known. Okay, then it follow normal distribution, and we compare the test statistics value with the tabulated value. Now, when we deal with very large data set, so it is very difficult to compare the value of test statistics manually with the table value. So what we do is we derive the probabilities. Listen to me again. So in spite of comparing the test statistics value with the table value, tabulated value, so what we do is we derive the probabilities. So what type of probability we derive? We will see that what is the probability that test statistics value is greater than tabulated. Again, try to understand what I'm trying to say. So we will try to see the probability, try to find out the probability that what is the probability that our test statistics value is greater than the value critical point value, we can say. Okay, so now we know that our distribution is normal because whatever test we are dealing with, that is based on the assumption that our data set for normal distribution, right? So if the probability that we got after solving this expression, if the probability lie in this rejection region, okay, let us suppose if the probability is coming at 0.025 for the one-sided test, or it is coming at 0.001, okay, for the two-side test, right? So it means that our probability value either lie on right hand side on this part, or either left hand side on this part, or it can be lying on the both sides. But it value is when we accumulate this probability value, it can't goes beyond 0.05. Okay, so there's a criteria that is exists in the literature that if we got the p-value of the test statistics directly, because when we use softwares, they only give the p-value. Okay, so if we got the p-value, and we just have to do only one thing, and based upon that, we are going to make a statement whether we are going to accept or whether we are going to reject that. What is the criteria? So if our alpha is greater than the p-value, or you can say that our p-value is less than alpha, then automatically we reject the null hypothesis. For example, if I assume alpha as 0.05 and the p-value that I got from here as 0.001. Okay, so you can directly say that your null hypothesis is incorrect. And if our p-value is coming to be higher than the value of alpha, then we are not going to reject the number. So this is the beauty that I can say that because nowadays we are using software, we are not solving these problems manually. So you must be aware about the concept of p-value, because whenever we see the output either from any software, either from R, Excel, SPSS, SAS, right, JASP, so they only provides the p-value. So p-value is very important, right? So just have to remember this condition. The p-value, if it is coming to be less than alpha, then we reject the null hypothesis. Otherwise, do not reject. So this thing is clear, I think. So this is one example. What example says that we have a sample mean as 2.84, right? The mu is given as 2.84. But actually the mu value is 3 because it is defined as the null hypothesis. Under null hypothesis, we define mu as 3. Okay, so we want to cross check whether our sample mean is a sample function. So this is a random variable. We want to cross check whether the sample mean is less than 2.84 or not. And here, from where you will get the this 2.84 come from here, right? X bar. So we compare this X bar with the 2.84 and try to see that what is the probability that X bar is less than 2.84. So if the value of this 2.84, the probability after solving is lie in this rejection region, because it is coming as 0.228 and our rejection region is 5%. So it is less than the alpha value. So it's like the rejection is, so automatically you can say that we're going to reject the statement that in the US there is at least 3 TV set in the home. Hope the idea is clear to you. So okay, so there is one more example in which we consider the upper tail test, and we are assuming that sigma is known to me. Now this is the difference. So sigma is known to me, we go with the jet test and upper side test. So we have a null hypothesis that on average, okay, let me read the statement for you. A phone industry managers thinks that customer monthly cell phone bill have increased and now average over $52 per month. So now they are making a statement that the average is not $52 per month. So this is null hypothesis that they have constructed, and alternate hypothesis that is more than 52. Because they want to prove this statement that it is more than 52, that's why they have considered the opposite of that in the null hypothesis. Okay. And they have considered alpha as 10%. And what is our main objective? We want to make a conclusion whether we are going to reject the null hypothesis or not. Okay. So based upon the alpha as 10%, we got the critical point as 1.28, sorry. Okay. And if any value goes beyond 1.28 of the test statistic, then we reject the null hypothesis. Clear? And how we do that? So this, they have shown that the value of this 10% is coming as 1.28. Okay. I'm skipping this part. So I'm coming directly to the expression that is required for you to understand. So they have taken a sample of 64, okay, in which they got sample mean value as 53.1. So put the value 53.1 in the expression of X bar, mu is given as 52, sigma is given as 10, and n is given as 64. So after solving, we got the expression of Z as 0.88. So you can easily see that 0.88 is less than 1.28. Yes or no? So it means our value of Z lie in this region. Okay. So it means whether we should have to accept or reject the null hypothesis. Anyone can answer this? Okay, I got one query that are there times that you don't rely on the p-value to determine significance or rejection, no rejection, like when the data set is very large? So basically there are two terms. Okay, one is called p-value and second one is called adjusted p-value. Okay, so although those things I'm not going to cover today, but sometimes if p-value we are not very much satisfied, then we go with the adjusted p-value. That depends upon the different situation. So, but there is no such situation I have observed that we should not rely on p-value. So we can either switch to adjusted p-value if we think there is some biasness with the p-value. Kifasi, I think I tried to answer your question. Right. And I think there is no any case I have observed that when the data set is very large, then so when the data set is very large, then automatically all the data set follow normal distribution. And I think there is no such any relationship that data sets very large has any impact on the p-value. So there is a criteria that is called adjusted p-value and p-value. That's a different thing. But I have not seen such case that for the large data set p-value is invalid. Okay. Are you able to understand what I'm trying to say? If I see, I think, are you there? Okay. So in that case, when the value of the test statistics lie in the acceptance region, so we are not going to reject the null hypothesis, and we can state that there is no sufficient evidence that the mean bill is over 52. And we can also derive the p-value for the same case, and we got p-value as 0.1894. That is very higher than 0.10. So we can directly say that we are not going to reject the null hypothesis. Okay. So we will consider two-tailed test tomorrow. And before that, I want to introduce to you one thing that is called R software, because I got a request from sir that audience wants to know about R software. Okay, let me give you a brief about that. So basically, this is R Studio that I have opened. So, but first, let me tell you what is the difference between RStudio and
Excuse me,
RSoftware.
sir.
Yes, sir. Yes.
There are some participants who are not familiar about how they can download RStudio
Yes,
and
sir.
R.
I'm going to do that. That means,
Yes.
so we have proper steps for that. So let me
Okay.
open my PPT, then I will explain to you. So basically, what is R? So R is a you can say coding based software in which there is no such option of clicking and getting the output like SPSS and SAS. So we have to write a code to do any calculations, right? So it is purely, you can say, coding based software like Python. Okay, so now you can see that why we use R, because it is an open source. There is no fee involved, that means, or any license fee you have to pay to install or run this software. So one can install this software of R from the CRAN website. Let me open that link for you if it is given there. Otherwise, I will open it directly. So this is the link, cran.rproject.org. Okay, you can when you click on this link, you will get you can see these options. I think all of you are with me. So you, based upon the you can say operating system that is installed in your PC or a laptop, you can install that thing. So you just have to click on download R for Windows. If you're using Windows, if you're using Mac, then you can download R for Macs, and if you're using Linux, you can download R for Linux. Okay, so now when you install this, when you download this, then you can install this. You will get such type of interface. I think if it is working. All of you are with me or not? So because based upon your response, I will proceed further. So which textbook you are preferring, Ishan? Please help to realize the link. Okay, so I am referring some books for you. So if you want to read further about this. So Introductory Statistics by Prem Singh Man, and in the Indian adapted version, I'm also the co-author in that. That is published by Wiley. Okay, and whatever things I am discussing with you, all those things have been discussed in detail. Okay, if you can see the text, so whatever the examples I'm discussing with you, most of the examples can be taken from that. Okay, you can correlate the things that I've discussed with you today. So sorry for the interruption, but I'm trying to say. So this is the interface of our software, and you can see that it is not very user friendly. So you have to write the code here. So whatever the code you will write here. So if you want to execute it, you have to first select it. Then you have to either use Control plus Enter. Let me see. Copy it and paste it, and you will get the response. So to make it more user friendly, so there is another user interface that is called RStudio that was introduced in the market, you can say, or in the website. So when you go to this link, RStudio, or either you can directly download RStudio, the link that was showing there. So you have to download this, but first you have to install R software, then you have to install RStudio, then only it will work. Because basically what is going on here, so RStudio is a user-friendly interface that works. That means that takes help of R software at the backend. So whatever
Sir, you are not audible.
Hello.
Hello.
Can you hear me? Sorry, I got disconnected.
Yes,
I
yes,
don't-
yes. Yes, sir, it's fine now.
Okay.
Please share the
So-
screen.
Yes, yes. So please let me know where you were there. That means till what stage I have covered. Whether I have discussed with you the R Studio, how to download it and how to. Hello.
Yes, sir, please explain how we can download the R Studio.
Okay. So now you have to go to this link R Studio. When you type on the, so you have to go to this link http www.rstudio.com. You have to click on this. I think my internet is not very fast now. Okay. So now you can see that. So based upon the requirement, you can install the R Studio version, because there are three types of R Studios available. One is for, that means when you also want some space, that means for web page also something. So we only need R Studio simple one. So you can download it directly from here. Maybe that page is working. Yeah. So R Studio desktop. So when first you have to install the R software, then you can install R Studio. So the link is already, you can see, and you have to install it first, download it and install it, like any other software we used to download and install. Right? Clear? So now when you install the R Studio, so the interface of the R Studio is such like that. Okay. So although I was working with various codes, so you can see that there are a lot of scripts are open, right? But let me tell you what they are showing. So when you want to write any code, you have to click on this, either on this tab, then click on R script, or either you can click on file first, new file, then R script. Both will give you the same output. That means that will open a R script. So why we prefer to write a code in R script? Because if you write directly code in the console, so this is a console where your output will be displayed. Okay, you can't edit the code, right? So it is better to write code in the script file. Okay, so let us suppose I want to do simple operations, 2 plus 3. Then I use a command that is called, either I can go to run, then it will be executed, or what I can do is I put the cursor at the end of the line, then I click use a short keys as control plus enter, right? So when I execute this command, when I execute this key control plus enter, then I will get this output, the same output. So here this is called a tab in which whatever the variable name we will use and whatever value we assign to them, that will be stored here. Okay, so we can see that we have an environment in which it is empty now. So let us suppose I have stored the value of x as 3. So I executed by using the command control plus enter. So you can see that now it stored the value that x consists of value 3 in its environment. Okay. History means whatever the operations we have done in the past, that is shown here. Connections, whether you are connected to any other external portal or something, that can be shown here. Tutorial means if you want to learn about more about different packages and code, you can learn from here. And at the bottom there is another tab in which we have files here that shows that in my working directory which files are showing, right? I can change my working directory also. Okay, and what are the plots we will construct, that will be shown here, and how many packages I have installed in my R Studio, that can be seen from here. It take some time because we are using internet. So these are the packages that I have installed in my system. But if I want to use any other package, I have to check on that. Okay, help means, so if you want any type of help, that means what is the syntax to write any function, you can type down, you can write your help. So let us suppose I want to know about what is the main. Okay, I click on that. So because my internet is, I think, not working very well, so that's why it is showing internal server error, or it will take some time. Let's see. Okay. Viewer and presentation. You can nowadays one can also construct the PPT in the R software. One can also construct HTML document in the R software. One can also construct Word file in the R software. Okay, in which we can incorporate code as well as output. Okay, we can also construct PDF file in which you can write the text, then your code, then your output. So that file is called R Markdown files. So you can prepare those things here. So now, first I am going to do only some basic operation. Tomorrow we will conduct the things, that means we have covered today the testing part tomorrow, because it needs some more time to explain the syntax. So you can easily see that in the R you can do the operations. What are the operations we used to do in the calculators, right? You can multiply, you can divide, okay, you can plus minus, each and everything can be done. Okay, you can also construct loops. I think if you have heard about for loop, if loop, we can also do that. And what's the purpose of for loop? So let us suppose if you want to do the same operation multiple number of times. Okay, so using for loop, we can do that. So if you want to do any operation number of times with a condition that you will repeat the code, you will repeat the syntax till the time when the value of the repetition is less than 10 or 50. For that, you can do if and while syntax. So now I'm going to stop for today's session. So if you have any query regarding today's session, we will discuss those, and otherwise we will continue with the R programming tomorrow, as well as the remaining topic like testing of 2 sample and testing of more than 2 sample. Okay. So now the session is open for discussion.
I have, thank you, sir. Excellent explanations. I have just one question. I know also the book of Dr. Maheta Dawal. Do you maybe know for R? Could you compare maybe these books?
Which one, ma'am? I'm not able to understand the name of the book.
I will write in chat.
Okay, which book? I have not seen. Can you send it again?
Yeah, please check in the mail, in the chat.
Okay, Dhaval Mehta, I think he's he's a professor in some of the private university, and he has posted some YouTube videos also, right?
No. I'm talking about his book on R. It's very good.
Okay, so you are saying that book is very good one.
How to
Or
say?
asking.
Useful.
No, you are asking my opinion, or you are saying
Yes, your opinion, yes, of course. If you maybe know the book.
Okay, let me see the content of the book, then I will let you know, because I have not gone through the content. How I can say make any statement without seeing the content, right? So let me see the content, then I will say.
Okay, thank you.
There are a lot of other books available in the market that I have observed myself. You can refer to the book. Let me tell you the name of the book. Our Companion.
Okay, thank you.
Let me see whether it is. So this is one of the book by one author, and there is one more book, Our Companion. So I will send you the list of the books that are useful for you to learn R. Okay, and even if you can see that there are a lot of videos that is introduced by Indian government. That means if you can see NPTEL, I think if you're not heard about the term NPTEL, let me tell you, NPTEL is a site in which famous, you can say, academicians from India, that from IITs, from higher institutions, they prepared videos for the students. Okay, they prepared lectures on various topics. So if you can refer those videos, that is also very helpful. This is my suggestion for you. If you want to refer, then it is up to you. Otherwise, I will search some of the names for you. And any other question from the audience? And let me know whether you're able to understand today content or not. Because based upon it, I have to modify tomorrow lecture. I think you can watch NPTEL lectures outside India. There's no such constraint. Hello.
Dear participant, any more question, please? Any question? I think there is no more question.
Okay.
Yeah. Thank you, dear professor, for nice presentation. And I hope that all the content which you present are very informative, knowledgeable, and will be very useful in the coming sessions. Dear participant, I have shared feedback form, and that is very, very important for the coming sessions. So please submit the same. And further, if you have any question, because now we have started to work on R programming, that is also mandatory, and all of you must have this software in your system. If you have any challenge or any problem, please let us know in the coming session or by tomorrow, or also you can drop message in the WhatsApp group. All of the participants are in the group. Okay.
Because tomorrow we will do whatever things we have covered today in our program.
Yeah.
And
So
I will also,
yes, sir. Yes, sir. Please.
I will also try to reproduce the same thing in Excel, because sometimes you can want to see whether the results are coming correct or not. You can compare the same thing in Excel.
Yes, sir. So once again, thank you very much. Thank you for delivering an insightful session on statistical inferences as a part of our 10 days biostatistics workshop. Dear Professor, your expertise and clear explanation have significantly enhances our understanding of this crucial topic. The practical examples you provided made complex concept accessible and engaging for all the participants. We greatly appreciate your time, effort, and valuable contribution to the success of this session. Your session was undoubtedly enriched our knowledge and sparked further interest in the field of biostatistics. So thank you very much once again, and thanks to all the participants. And please don't forget to submit your feedback. The link is available in your WhatsApp group. Tomorrow we will join at the same time. Thank you very much, and good night from India. Good night to all.
Thank you very much. Good night.
Thank you. Thank you.
Thank you to all.
Okay, sir. Thank you.